Hello everyone, today we are conducting our MOSFET lab, and today firstly we are looking at our DC operating points of the MOSFET, and by doing our measurements we will calculate the threshold voltage and the conduction parameter. After that, from the measurements we got, we will compare them with our calculations and see the error percentages. So to begin with, in here, if we have a look at the transistor, the MOSFET, when the flat side of the transistor is looking at you, this is the drain, this is the middle one is the gate, and the top right is the source. And I connected like this to not to short them. Okay. So to begin with the first part, I conducted the circuit. I built the circuit like this. The drain and the gate is connected. They are shorted, and there is a 1 kilo ohm is connected. And from the top of the 1 kilo ohm, we will give our supply voltage, and our source node is connected to ground. So to begin with, I will connect the positive DC supply to here, and I will connect the ground to the source. Okay? And in the first part, it asks us that adjust the voltage until voltage drop across the 1 kilo ohm resistor is about 2 volts. Okay? So to begin with, I will put the multimeter probes to the 1 kilo ohm like this and start to adjust my DC supply so that the voltage drop across the resistor is 2 volts. Okay? So now I'm very close, it's 1.3. So a bit more will fix this. Okay. I'm trying to not increase it in a very fast manner, because if I increase it very fast it might damage the transistor. So okay, around 4 volts or 3.9 volts I'm getting the 2 volts across the 1 kilo ohm resistor. So now, firstly, I will measure the VGS, which is the middle node here, and the top right node here. I will measure the voltage across that. So what I do is, I will put my probes like this, and the VGS is around 1.6. And after that, I need to measure the ID1. To measure the ID1, firstly I close the DC supply, and in here I switch the probes for the correct positions for measuring the current. So I press shift and to the current mode. So what I do is, since we will measure the ID, so I will I will serially connect the amp meter like this. So this is the positive part. This is the positive part of the our input, and this will touch the upper side of the resistor. Okay. So again, I open the DC supply, and in order to measure the current, I will touch the leg of the resistor, and as you can see here, it is around 2 milliamps. Okay. So after this, again, in the second part, we need to make the voltage across the 1 kilo ohm resistor as 4 volts. Okay. So for the voltage measurement, again, I change the probes and go to the voltage. And here, I give the supply from here. Okay. So again, I will look at the voltage drop across here, the 1 kilo ohm resistor, and open the supply. Okay, so now I was left in the 2 volts, so I need to increase it a bit more. So starting from like this, increase it like this. Okay, and okay, so around 5.9 or 6 volts, I get the voltage drop across the 1 kilo ohm as 4 volts. So now, again, I need to measure the VGS now. So, like in here, I will touch the middle leg of the transistor and the top right leg. So I will measure it like this. So our VGS is around 1.7 now. Okay. So after this, for the last part, we will measure the ID. So again, change the probes for the current measurement and set the multimeter to the current measurement mode. And after that, I will firstly close the supply. Okay. So what I do is I serially connect the amp meter. So in order to do that, I will connect one probe like this to the DC supply, and other probe will touch the leg of the resistor so that we will measure the current. So we are in DC current, and when I open this up, it is around 4 milliamps. We measured the ID and VGS for both cases. Now we can calculate our threshold voltage, the conduction parameter, and we can compare our values with our calculations. For the second part, we are now building a common source amplifier. So first of all, we will build the circuit that is mentioned in the lab manual. So firstly, if you look at the circuit, before going into that, I want to remind you that so the left leg is the drain, the middle one is the gate, and the right one is the source. So in here, from the drain, we have our D1 connected to the plus 5 volts here, this guy here, and in here, the gate is connected to the, first of all, there's a voltage divider between R1 and R2, so we construct the voltage divider such as these are 200 kilo ohms connected in series that is going to the plus 5 volts, and one more 100 ohms, 100k ohms is going to the minus 5. So we will have the required voltage here. And for the source part, we have 240 ohms, and I used 220 ohms in series to construct the 140, and that is going to the minus 5 volts as well. And the capacitor, the CS capacitor, is here. Here we are seeing the load capacitor here, and for the DC blocking, this is our connection to the gate, and where we will give our DC, where we will give our AC input. Here we have this capacitor here. So firstly, to begin with, we are measuring our DC operating points first, as we done in the first part. So to begin with, I mentioned to you that this is the 5 volts and this is the minus 5 volts, and here, this node here is our ground, okay? This is the RL resistor, and this is our ground. So we can use this here as a ground, and we can measure the voltages for the gate, source, and the drain. So I will put one probe to the ground here, and to begin with, I will touch the drain first. Sorry, I was in the AC. So not in AC, I was in the current mode, so I need to switch to the voltage. So this is the ground, and in here I'm touching the drain. So around minus 1 volts I'm seeing in the drain. Let me touch a bit more. Okay, so this is minus 1 volts, around minus 1 volts. And now I'm measuring the gate. So here, this is the gate. So it is around minus 1.64. And lastly, my source, I'm touching the source, and it is around minus 3.5, 3.6. So now we conducted our DC operating points. Now we can give the AC input from the gate. And for the input, I connected a jumper that is going to the function generator of the oscilloscope. So to begin with, here 1 of the probes of the oscilloscope, the channel 1 is connected to this probe here, this jumper here, and one probe, the second channel, is connected to our output, which is the voltage across the RL in the circuit. So firstly, open the function generator. So in here you're seeing that the yellow signal is our input and the green signal is our output. So now first of all we are seeing a clipping. In order to fix that, we need to decrease our input because we want a sinusoidal signal at the output as well. So in order to do that, we are decreasing our input. So it was 1 VPP and we are decreasing it in order to get another sinusoidal at the output. So decreasing, further decrease it. So now we fix the top level and now we have to fix the lower level, so to keep decreasing. So yeah, around 200 milli VPP we get what we want. So just to be sure, I select 150 milli VPP. So in order to see our gain better, I adjust the horizontal angles from here. So now each part here for the green signal is 1 volt, and for the yellow one each block here is 0.5 volts. So if I change it to 100 millivolts for the yellow one, as you can see our gain is around 10. So, and from our measurements you can compare your results with your calculations and calculate the error percentage. So now we have completed our MOSFET assignment. So that's it. Thank you. So for the last part we will sketch a body plot by playing with the frequency in the function generator. So we will see that lower 3 dB and upper 3 dB points. So in order to do that, for the ease of calculation, I arrange my amplitude in the input amplitude such that the maximum gain, from the maximum gain we will get, the output is 2 volts. So from that we will look at the lower frequencies that we will get 1.41 which will correspond to our 3 dB points. So in order to find the lower frequency, firstly I will decrease the frequency from here. So let's decrease it further. Because I'm decreasing the frequency, I need to also enlarge the time scale, the X scale. So I will enlarge it a bit more. So still I have around 2 volts, so I will decrease it further. So now it starts to decrease. Okay. So further a bit more. So yeah, around 59 Hertz we are having our lower 3 dB frequency, and we are getting 1.41 volts. So here, and if we increase it, decrease it further, you will see that it is decreasing more. Okay, so let's go back to our original frequency, 1 kilohertz. Okay, since I'm increasing the frequency, I need to also decrease the time scale. So 1 kilohertz. Okay, so now I'm back to 1 kilohertz, and again I'm having 2 volts peak to peak. So now I will increase my frequency in order to get the upper 3 dB point. So now I'm increasing the frequency. Since I'm increasing my frequency, I need to decrease my time scale. Okay, so still we have around 2 volts, so now decrease it more further. So at the same time decrease the time scale. Okay, so we are now around 100 kilohertz and we still have 2 volts, so we need to increase it more. So now around 600 kilohertz we have a start to decrease. Okay, so now I will further increase the frequency. So around 2 megahertz, 2.1 megahertz, we have our upper 3 dB frequency. And now from there I will increase it more to see what happens. So as we can see in the lower frequencies, now the amplitude is getting lower and lower. Okay, so we now calculated and measured everything that is asked in the lab manual, and we have completed our lab assignment. Thank you.